MJ Church adopted a digital-centric approach to plan, manage and deliver a highly complex excavation and backfill operation at the M27 Junction 10 scheme over a small 2025 Christmas possession window. The project featured the excavation of approximately 22,000 cubic metres of clay and chalk material to form a safe working void to enable the installation of an 8,500-tonne concrete underpass via hydraulic jacking. The works were undertaken on a critically important part of the strategic road network, which is utilised by thousands of motorists daily. Thus, to avoid any disruption or delay to the reopening of the M27, precise planning and coordination was critical. Producing a fully optimised and agreed upon 3D model was key to the success of this operation. With a very tight programme and no room for error during the possession, it was essential that the construction approach was fully understood and all parties were brought in. MJ Church once again deployed a model-driven approach to dictate the construction process. We developed the construction models in full collaboration with our client VolkerFitzpatrick. Trimble Connect common data environment was used to host and optimise a detailed 19-phase construction model. Each model phase contained multiple embedded guidance services that controlled the excavation sequence, benching, geometry and controlled backfill and rigorous compaction operations. These models form the basis of the construction plan. Phase 1 featured the advanced excavation of the northern M27 embankment to form a stable 1 in 1.5 slope to maintain the stability of the live carriageway and reduce the excavation volume required under possession. Phase 2 involved a similar advanced excavation operation on the southern side of the M27, this time involving working in close proximity to previously installed sheet piles. Phase 3 to 12 provided the bulk excavation and benching profile down to a 0.5 metre surcharge level. The excavation was controlled in 1 metre drop intervals using operator selectable guidance surfaces, which coincided with the bench landings, ensuring they could be graded to an exceptional quality. Phase 13 provided the final trim geometry, including the 70-degree side slopes and finished formation levels, which were trimmed to perfection as the underpass was hydraulically pushed forward. Phase 14 to 17 provided several surfaces to guide the structured placement of the 6C, 6N and drainage ballast backfill material to fill the void between the underpass structure and the benched M27 excavation profile. Phase 18 to 19 provided the earthworks outline for the revised M27 embankment slopes and the M27 carriageway reinstatement geometry and various material layers. Full 3D modelling of the anticipated construction sequence allowed for early identification of potential access and egress constraints, holistic quantification of volumes, and realistic outputs. This work was used to directly inform the construction programme and provided our stakeholders, VolkerFitzpatrick, Hampshire County Council and National Highways, with the confidence it could be implemented successfully and safely during the possession window.
Before work started on site, we carried out a full digital rehearsal of the sequence led by an MJ Church digital rehearsal handbook. This allowed the team, from plant operators to supervisors, to have a full understanding of the 3D geometry of the works and identify any clashes in sequencing, access or planned approach early on. This digital rehearsal process significantly de-risked the works. It provided confidence that the excavation, box slide and backfill could be carried out to the required design, specification and tolerances. From a health and safety perspective, this approach allowed all parties to clearly understand the number of machines operating at any given time, where machines would be positioned for the different phases of work, how people would move around the excavation safely, and how those interfaces would be managed in a confined space with a large workforce. It helped bring the plan to life in a technical but easy to understand way that simply isn't possible with traditional 2D drawings or PDFs. During the possession, live excavation was tracked using machine telematics and reported back to the project team through Trimble WorksOS, allowing the project team to closely monitor production against program targets and respond quickly if adjustments were needed. WorksOS facilitated the reduction of people-plant interface as it meant excavation levels could be verified by the engineers away from the works. We also had a robust contingency planning in place, including physical checks of the machines and calibration of buckets and blades to maintain accuracy throughout the works. Tools like Trimble Site Vision help the team continually reference the design geometry on site and verify that the works being carried out match the model and design.
The level of digital planning and collaboration on this project played a major role in its successful delivery. It gave Hampshire County Council, National Highways and our client VolkerFitzpatrick confidence that MJ Church could deliver a complex and high-risk activity within a very constrained possession. By combining detailed upfront modelling, clear project breakdowns and live performance monitoring, we were able to maintain programme certainty, manage risks and deliver the work safely and efficiently. This project, alongside other possession works being planned and delivered by MJ Church within a busy and demanding period, at the same time is a strong example of how MJ Church's digital engineering approach, when fully integrated with operational delivery, can improve safety, accuracy and confidence on even the most challenging infrastructure schemes. We are pleased to be a major contributor to the successful completion of this scheme, mitigating extended and unwanted disruptions to the wider road user network.